Hello everyone, I hope you all are doing well. So today we are going to discuss about a very important topic in Azure storage, and that is regarding disaster recovery and storage account failover. So let's start. So as we all are aware that Microsoft stores multiple copies of our data for the sake of durability, protection and availability. Likewise, one of the solution that is there is geo-redundant storage. That is storing data in couple of regions instead of only one. And over here we have a primary region and a secondary region. So the concept of failover only applies where geo-redundant storage is enabled. That is two options, GRS or GZRS. Failover will be applicable. So what happens during the failover when the primary is not available, then the secondary region serves as the primary endpoint and the customers or the person utilizing the Azure storage is least impacted. So the failover does that it updates the secondary endpoint to become the primary endpoint for your storage account. Once the failover is complete, clients can begin writing to the new primary endpoint. Let's move forward. We must choose the right redundancy option for utilizing the failover concept. So there are two options as I already told you, GRS and GZRS, and then there is read access for the geo replications that are available. So with GRS or GZRS, what happens is that read access won't be available to the secondary endpoint when the failover is going on or during the normal times as well. While with read access enabled GRS or GZRS, you will have read access to the secondary endpoint even if the failover is going on or at normal basis as well. So you will always have read access to the secondary endpoint regardless of the primary. Be aware that write access is not available at the normal times, and write access will only be enabled when the secondary becomes the primary after the failover. Let's move on. So there is a warning and it is very critical. Geo-redundant storage carries a risk of data loss. Data is copied to the secondary region asynchronously. So as I already had told you in the last video, asynchronously means that there is a delay between the copy of data that is written to the primary region to be replicated to the secondary region. And in the event of an outage, write operations to the primary region that have not been yet replicated to the secondary will be lost. Although there is a solution that we can refer to for deciding what will be lost and what won't be lost, and it is the sync time that I'll be talking about later. Now let's understand the account failover process. So a customer managed account failover enables you to fail your entire storage account over to the secondary region if the primary becomes unavailable for any reason. When you force a failover to the secondary region, clients can begin writing data to the secondary endpoint after the failover is complete. The failover typically takes about an hour, but there is no committed SLA to be honest. Under normal circumstances, a client writes data to an Azure storage account in the primary region. So as you can see in the picture, the customer is writing data to the primary region and it is being asynchronously replicated to the secondary region, which means there's a delay in the replication. Okay, it is not happening simultaneously. Let's move on. Now, if the primary endpoint becomes unavailable for any reason the client is no longer able to write to the storage account. So as you can see, when the client was writing to the storage account, now if the primary region has become unavailable, then he won't be able to write to the primary region, and the replication will also be stopped since there is no write operation. In this scenario, we will move on to our next step, that is the customer will initiate a failover to the secondary endpoint. During the failover, the DNS entry provided by Azure Storage will become updated to the secondary endpoint, and the secondary endpoint, that is the data in the secondary region, will become the primary now. Okay, and write access will be restored for the geo redundant storage accounts once the DNS entry has been updated, and all the write requests will be directed to the new primary endpoint. All the storage services will be restored after the failover. So this is the simple concept of failover. That is, the secondary endpoint is updated in the DNS entry, and everything now happens at the secondary region as it becomes the primary now. Let's move on. Now there are some critical and important points that I would like to highlight. Once the failover is completed, the storage account is configured to be LRS in the new primary endpoint. To resume replication to the new secondary, configure the account for geo redundancy again. Keep in mind that converting a locally redundant storage account to GRS again incurs both cost and time. An account failover usually involves some data loss. It's important to understand its implications. Since the data is written asynchronously, there is a delay between replication, and the data that has not yet been replicated to the secondary region before the failover might be lost. When you force a failover, all data in the primary region is lost, as the secondary region becomes the new primary region. All data already copied to secondary is maintained when the failover happens. However, any data written to the primary that has not yet been copied to secondary is permanently lost. Now, it is a very important concept of the last sync time. It indicates the most recent time that data from primary region is guaranteed to have been written to secondary region. So it means that after this time, if you initiate the failover, the last sync time will indicate that after this is the last time that the syncing has been done, post which that particular marker, the data won't be lost because it has already been replicated. Okay, so suppose the last sync time is at 11 a.m. right, and you have initiated the failover at 11:10 a.m. Then the last syncing that was done, till that time the data will be there in the secondary region. Let's move forward. Now let's talk about failback to the original primary again. So failing back is just a vice versa process of the failover, but it has some certain amount of complexity or more amount of steps compared to the failover process. So after you fail over from the primary to the secondary region, the storage account is configured to be LRS in the new primary region. You can then configure the account in the new primary region for geo redundancy. When the account is configured for GRS after failover, the new primary region immediately begins copying data to the new secondary region. So when you are enabling geo redundancy for LRS account, it is usual that the data will now again be replicated to the new secondary region. So this new secondary region was the primary before the original failover has taken place. However, it may take them some time before existing data in the new primary is fully copied to the new secondary. After the storage account is reconfigured for GRS, it's possible to initiate a failback from the new primary to the new secondary. In this case, the original primary region to the failover becomes the primary region again. So what is happening is that now you are again failing over from your secondary, from your primary to the secondary. So what will happen? You are failing over twice. So again the initial settings will be restored. That is, now your primary region that was earlier will again become primary. But this time around it will be either LRS or ZRS, depending that you configured it as GRS or GZRS. Okay. All data in post failover primary region is lost during the failback. Okay, so the secondary region data will again be lost. Okay, and the new primary will have all the data that is there. If most of the data in the storage account has not been copied to new secondary before you fail back, you could suffer a major data loss. So this was all about the failover process and the disaster recovery solution that it provides, and the failback process as well. I hope it was a conceptual and logical video for you all and help to gain further knowledge. Thank you for watching. Please